All right, this is the review for Exam 5 coming from Chapter 7 and 8. It also has a section 3.6. And you'll have to forgive me, the stylus broke that I usually write with. So I'm writing with my finger. If the handwriting's a bit messy, I apologize, that's why. Okay, question 1. You're identifying the vertex here, focus, directrix, and then sketching the graph. Now it says of each, there's only one. It doesn't specify what we're going to be graphing. So first thing that you notice is y is being squared, but x is not. So there's going to be a parabola. We're graphing a parabola. This is from section 7.1 if you are wanting more practice or more problems to look at. Now, in conic form that we learned in chapter 7.1, it's the squared variable that you want to get by itself. So if you multiply by -3 on both sides, you end up with the equation y squared equals -3x. And then what we learned in 7.1 was to take the coefficient of x and set that equal to 4p. So p equals -3/4. And the value of p helps you find the focus and also the directrix. Now, because there aren't any parentheses, like x minus something equals parenthesis y minus something squared, there aren't any transformations. So we know the vertex is the origin, 0, 0. So there's one point that we know right there. And then the focus is -3/4. Now what we'd have to decide is what kind of parabola this is. Is it facing up, down, left to right? P is negative, which is important. And because y is being squared and not x, but y is being squared, this is a horizontal or a sideways parabola. And since p is negative, it's facing to the left. So the focus is the point -3/4 comma 0, -3/4 comma 0. So -3/4 puts the focus about right there. And then the directrix would be +3/4, so it's a vertical line going through +3/4 right about here. So the parabola is going to look something like this, but what we need to have is the exact width of the parabola. So that was done by using the focal diameter. And that's equal to the absolute value of 4p. We saw up here that 4p was equal to -3 right here. So the focal diameter is the absolute value of -3, which equals 3. So that means the whole segment of the focal diameter is 3 units. So starting at the focus, right here, starting at the focus, you're going to go up 1.5 units and down 1.5 units, making a total length of 3. So up 1.5 right there, down 1.5 right about there. And then the parabola goes through those 3 points. Okay, so for question 2, it says use the information provided to write the conic form equation of this parabola. Vertex is at the origin. The focus is 3/4, 0. So the focus is on the x-axis. that makes this another horizontal parabola. And if it's a horizontal parabola, that means it needs to be modeled after the equation y squared equals 4px, where 3/4 is the value of p, so p equals 3/4. That means 4p would be 4 times 3/4. The 4's cancel, so 4p equals 3. So that's the value that you would put right there. So y squared equals 3x. Now, it says a couple of things here for these. Identify the vertices and the foci, sketch the graph. It doesn't specify whether these are parabolas, ellipses, or hyperbolas. However, we've got an x squared and a y squared on question 3, which implies it's going to be either an ellipse or a hyperbola. So what needs to happen is grouping terms with similar variables together. So the 4x squared and the 16x, you would want to group those together. Same thing with the 25y squared and the 250y. So looking at the x variables, 4x squared and 16x, if you factored out a 4, you'd have x squared plus 4x, and then we're going to leave a spot there to complete the square. And then doing the same thing for the y variables. So if you factor out the 25 from the y variables, you're going to have y squared plus 10y plus blank. And if you move the 541 so over here with the x's, right here, it's going to take a 4 to complete the square. And then if you look at the 4 that was factored out, multiplied by that 4, you're going to be actually multiplying 16 on the left side, so you've got to add 16 over there. And then with the y variables, y squared plus 10y, 25 is the value there that completes the square. But you have to consider 25 times 25, which is 625. So you're adding 625 to that side. So the expression becomes 4, and then x squared plus 4x plus 4 is x plus 2 squared plus 25, and then that's y plus 5 squared, and then if you add all of these up, you get 100, and then if you divide everything by 100 because you want to make it equal 1, so it becomes x plus 2 squared over 25 plus y plus 5 squared over 4 equals 1. And I'm running out of room to graph this, so I'll just go into this space here. So because of the plus sign here, this is an ellipse, and because the larger value here is underneath the x variable, it's a horizontal ellipse. It's been moved 2 units to the left and 5 units down. So let's add a graph here. If we go 2 units to the left and 5 units down, puts a point right there. So I recommended that you shift the origin and center it around that new point, -2, -5. Now with the x variable, this being a squared means a is 5, so plus or minus 5 in the horizontal direction because it's with the horizontal variable x. So 1, 2, 3, 4, 5, puts one vertex there. So we go out plus or minus 5 in each direction. Now this value there is with the y variable, that's b squared. B squared is 4, that means b is 2, so you go up and down 2 units in each direction. Okay, so there's your ellipse. We're just missing the foci. The foci use the equation c squared equals a squared minus b squared, where a squared is 25 here and b squared is 4 here. 25 minus 4 is 21. So c squared equals 21, which means the c is the square root of 21, which is in between 4 and 5. So there's a focus right there in between 4 and 5, and a focus somewhere right in between there. And again, I can't be real accurate, so I'm just using my finger here. But there are your 2 foci. Alright, for this one, there are no other x variables besides 16x squared, so we don't have to complete the square there. Now on the y variable, we do. So I'm going to factor out the -25, and that leaves y squared plus 2y. And if you move the 425 over to the other side, now there's a 1 that completes the square, but -25 and a +1 make -25. So if you factor y squared plus 2y plus 1, you get y plus 1 squared equals 400. Now divide everything by 400. Then that becomes 1. 16 over 400 and 25 over 400 are fractions that can simplify. So 16 divided by 400 is 1/25, so you get x squared over 25 minus, and then 25 over 400 is 1/16, so y plus 1 squared over 16 equals 1. So the minus sign here means it's going to be a hyperbola, and there isn't a transformation in the horizontal direction because it's just x squared, but there is a vertical transformation here down 1 unit. If we draw a graph and go down 1 unit, That's where we would want to put it or imagine a new coordinate system. With the origin now being right there. And this number is associated with the x variable, so we're going to go out 5 units in the x direction. And then since this is associated with the y variable, we're going to go up 4 units and down 4 units in the y direction, and then use that as dimensions for the central box. And then the horizontal or the slanted asymptotes going through the corners in the center. Okay. And these represent the vertices. Plus or minus 5. And then the slanted asymptotes are here to help give shape to either side. Of the hyperbola. And we're just missing the foci, and the foci have the formula c squared equals a squared plus b squared. 25 plus 16 is 41. Square root of 41 is a little more than 6, but less than 7. So if this is 6, 7, 6, 7, the foci are going to be in between, right about there. Okay. Now this one's going to be a hyperbola. And based on the location of the vertices, 0, 7, 0, negative 7, the vertices are on the y-axis, which means this is going to be y squared over a squared minus x squared over b squared equals 1. Vertices give you the value of a, foci give you the value of c. So you're going to want to use the equation c squared equals a squared plus b squared to find the value of b, because we've been given c and a. So if c is plus or minus square root of 149, that means c squared is 149. If a is plus or minus 7, then a squared is plus or minus 49. So this means b squared equals 100. That's the value that's going to go there for b squared. A squared was 49. That goes there for a. So the equation becomes y squared over 49 minus x squared over 100 equals 1. Okay, we've been given the explicit formula. We need to write the first 4 terms. The first term is when n right there equals 1. So if n equals 1, 5 times 1 is 5, plus 20 is 25. The next term, or the second term is when n equals 2. 5 times 2 is 10, plus 20 is 30. And if you recognize, this is the explicit formula of arithmetic sequence, and the 5 in front of the n represents a constant rate of change of 5. So you're going to be adding 5 every time. So the next term would be 35, the next term would be 40, and so on and so on. This here, we want the first 4 terms, and again, the first term is when we have an n value there of 1. When n equals 1, 1 squared minus 2 is negative 1. When n equals 2, 2 squared is 4, 4 minus 2 is 2. When n equals 3, 3 squared is 9, 9 minus 2 is 7. When n equals 4, 4 squared is 16, 16 minus 2 is 14. So, it says to find the explicit and a recursive formula, but it hasn't told us whether or not these sequences are arithmetic or geometric. So we need to look for a pattern here. And if we start at negative 20, then go to negative 220, then negative 420, then negative 620, it looks like we're adding negative 200 every time. So that's a common difference of negative 200. Common difference indicates an arithmetic sequence. So the explicit formula is the common difference negative 200 n plus, now the way this was instructed in class, if you think about there being room for a quote-unquote zero term, this right here is the first term. And if the pattern continued, there would be 180 right there, because 180 minus 200 is negative 20. So 180 fills that position. So the explicit formula is negative 200n plus 180. Now the other way to do this is the explicit formula, or the nth term, is the first term, negative 20, plus n minus 1 times the common difference. Okay, so that makes negative 20 minus 200n plus 200. And then if you combine the plus 200 and the minus 20, you get negative 180, or sorry, you get 180, which is what we had there. So you can use that formula if you would like. I'm going to erase that. Now it also asks for a recursive formula. So recall, a recursive formula is one that gives you a starting place, a first term, and then it describes a way to get to the next term. So this would be the explicit formula here. The recursive formula would be, all right, the first term a sub 1 is negative 20. The next term a sub n is equal to the previous term a sub n minus 1. And then the way we discovered that you get from term to term to term here is to add, or to subtract 200. So this right here would be the recursive formula. Okay, for question 9, from 30 to 27 to 24 to 21, looks like the common difference is negative 3. That indicates another arithmetic sequence. The explicit formula would be the common difference, negative 3n, and then the zero term, if there were a term here in front, so not the 9, but if there were a term in front of the zero term, it would be 33. So that's the explicit formula. The recursive formula is first term is 30, the next term a sub n is equal to the previous term a sub n minus 1, and then we're just subtracting 3 every time to go from the next term to the next term to the next term. Okay, this one just wants an explicit formula from 3 to 18 to 108 to 648. Looks like there's a common ratio. We're multiplying by 6. Now, the explicit formula for a geometric sequences have common ratios, is patterned after an exponential function. So a sub n is equal to the first term, a sub 1, times the common ratio, r, to the power of n minus 1. So the explicit formula, a sub n is equal to the first term, 3, times the common ratio, 6, to the power of n minus 1. Over here, to go from 2 to 1 to 1/2 to 1/4, it looks like we're multiplying by 1/2. Since it has another common ratio, this indicates a geometric sequence whose formula again is a sub n is the first term times a common ratio to the power of n minus 1. So first term is 2, common ratio is 1/2 to the power of n minus 1. Right, so question 12. We need to find the explicit formula given just two random terms of the sequence. Now, it says very specifically that we've got an arithmetic sequence, which means it can be patterned with a linear function. Now, if it's linear, that means there's a slope. The slope is the change in y divided by the change in x. If you want to think about input versus output, or x's and y's. In the case of functions, x's and y's, the 13 and the 38, those would be the x's. The negative 132 and the negative 382, those would be like the y values. So if we took the difference of the y values, negative 382 minus negative 132, that's the difference in y. And then if we took the difference in x, 38 minus 13. So 182, or negative 382 plus 132 is 250, negative 250, and then 38 minus 13 is 25. Divide that, and you get negative 10. So negative 10 is your common difference, because a common difference in an arithmetic sequence is a constant rate of change, or that's analogous to a slope of a linear function. So in general, an arithmetic sequence is, explicit formula at least, is a sub n equals a common difference d times n plus or minus the term in front of the first term. Now, we haven't been given the first term, so we need to figure out a way to find this term in front of the first term. So we can use an n value and an a sub n value, because we already know d here is 10, or negative 10 rather. So if we wanted to use this n value and that a sub n value, so we would have a sub n is negative 132 equals negative 10 times the n value of 13, and that's going to give us that unknown starting value. Negative 10 times 13 is negative 130. And if that gets added to the other side, we're going to have negative 2 is equal to the unknown value. So the explicit formula becomes a sub n equals negative 10 n minus 2. And it's never a bad idea to check. It says, according to this, for example, the 38th term right here, the 38th term should be negative 382. So for testing that, if we plug in a 38 for that n, 38 times negative 10 is negative 380. If you subtract away another 2, you're going to get negative 382. So it seems to work. That is the explicit formula, negative 10n minus 2. Okay. Evaluate each arithmetic sequence as described. It's arithmetic because you can see that we're just adding 7 every time, and they want us to add 18 terms. For an arithmetic sequence, The formula, and this was the story I related in class regarding Carl Friedrich Gauss and adding the numbers from 1 to 100. So if you remember, he added the first and last number. That made 101, and then you multiplied that by the number of pairs you could make from taking the first and last, and there were 50 pairs. So the formula was first term plus last term multiplied by half of the number of terms being added together. Now it says right here n equals 18, so we're adding 18 terms. We know the first term is 1, so that goes there, but we don't know the last term, a sub n. But using the first 4 terms given, we can quickly generate an explicit formula. A sub n equals the common difference 7n, and then if there were minus 6 as a 0 term or a term in front of the first term, if you add 7 to that negative 6, then you'd get 1, and then you get 8, and then you get 15. So this is the explicit formula. Now if we want the 18th term, you would plug an 18 in there for n. 18 times 7 is 126 minus 6 equals 120. So the 18th term is 120. So if we use the formula now, first term plus last term, that's 1 plus 120 multiplied by n over 2. Well, if n is 18, 18 divided by 2 is 9. So it's 121 times 9. 121 times 9 is 1089. So that would be the sum of the first term through the 18th term of that arithmetic. Now it says series here. A series is a sequence whose terms are being added together. Okay, question 14. It's been given in sigma notation here. Sigma notation signifies summation or adding together of terms, and we're adding 15 terms as it indicates there. And if you look at it, it doesn't specify necessarily, just by looking at problem 14, that the sequence is arithmetic. I know it says it in the directions, but if this were just a random question on an exam, you would need to understand that 9i minus 5 is a linear function, which denotes an arithmetic sequence. So we can use the same formula, first term plus last term multiplied by half of the number of terms. Now we're adding 15 terms, so n equals 15. First term, we can use the explicit formula here to get the first term. When I equals 1, that's going to give us the first term. So I equals 1 means 9 times 1 is 9. 9 minus 5 is 4. The 15th term would be 9 times 15 minus 5. 9 times 15 is 135. 135 minus 5 is 130. And this is going to be multiplied by 15 halves. So we've got 134 multiplied by 15 halves. And that equals 1,005. Now, number 15, evaluate each geometric series. The formula for the sum of a geometric series was first term, and then we had 1 minus r to the power of n over 1 minus r. Now, you can use the formula, however, we're only adding 6 terms here. And if you consider 2 plus 12 plus 72 plus 432, we only need 2 more terms, and it looks like the common ratio, if this is geometric, the common ratio is multiplying by 6. So if we were to simply find the next 2 terms, you could just add a list of numbers together rather than trying to use a formula. That might be a little more useful here. However, I'll show you how the formula works. So the first term is 2, and it's 1 minus the common ratio of 6, and then we're adding 6 terms, so n equals 6 over 1 minus 6. So this is 2, negative 5, and then 1 minus 6 to the 6th power is 46,656. And if you were to run this whole thing here through your calculator, you would get 18,662. Okay, we've got sigma notation, which denotes adding a number of terms. We're adding 9 terms together here. And the format of the explicit formula, since it's an exponential equation, means this is geometric, so we can use the same formula. First term, 1 minus r to the nth power over 1 minus r. So we're going to have this right here as our first term, negative 3. And the common ratio is there too. And we're adding 9 terms together. And if you run that through your calculator, negative 1,533. Now, question 17 says, evaluate the infinite geometric series. First of all, it's got to be geometric, and it already says that it is. The infinite geometric series can only be added if the common ratio r, or the absolute value of the common ratio, is less than 1. So if you look at negative 1 to 1/3 to negative 1/9 to negative 1/27, it appears that r equals negative 1/3, which certainly falls under that category. So if that's the case, if the absolute value of r is less than 1, then the sum of the infinite geometric series is the first term over 1 minus r. First term is negative 1. And just one little correction. R isn't negative 1/3. R is just positive 1/3. Negative 1 times 1/3 is negative 1/3 times another 1/3 is negative 1/9. So anyway, we've got 1 minus 1/3 there, which is negative 1 over 2/3. Negative 1 divided by 2/3 is negative 3/2. Now this one's an infinite series, or an infinite sequence, because of the infinity sign up here. And it's geometric because of the exponential function indicated there. And the common ratio is 2/5, which is less than 1. So we can do the same formula. Sum equals first term over 1 minus r. First term would be the 6 right there. So this is 6 over 1 minus 2/5, which is 6 over 3/5, which is 10.